Okay, today we're going to talk about prime factorization, and what that means is factoring out a number to its prime factors. Okay, so again, we're talking about prime factorization. So we want to be able to factor out a number so that you can multiply it by only prime numbers. So let me get that more in focus here. So we're going to do some examples. We're going to start a little bit easier. Okay, first of all, we need to remind ourselves what prime and composite is. Prime is a number that has exactly two factors. Okay, so for example, 5. Okay, the only way that I can get to that is saying 1 times 5. There's no other way to get to that. Okay, then composite is a number that has more than two factors. Okay, so example would be 9. I have 1 times 9, of course, but I also have 3 times 3. So this right here makes it a composite number. There's more than one way to get to that number by multiplication with whole numbers. Okay, so we're going to use that for prime factorization. So let's say that I start with, we're going to just do 36. Okay, if I have 36, I'm going to just kind of make a little tree branch type thing there. And 36, I'm going to think of two things that I can multiply to get to 36. And there's so many different ways you could do this. One way would be 6 times 6. Okay, so I'd say 6 times 6. Now I'm going to go from 6, and is there anything I can multiply to get to 6? Yes, 2 times 3. Okay, let me just kind of get a little bit closer here. So 2 times 3. Is there anything that can go into 2? No, that is prime, so I'm going to circle it. And 3 is prime, so I'm going to circle it. That's the end of that little branch. So here I have 6. And again, I can do 2 times 3. And those are prime, so I'm going to circle those. So that means the prime factorization to get to 36, I like to go in order from least to greatest, just to make it a little bit more consistent, would be 2 times 2 times 3 times 3. Now we've learned about exponents, and we can use this to kind of condense this. This would be like our expanded form, and we'll put it in exponential form. So there's 2 2's, not 2 plus 2, but 2 2's being multiplied. So there'll be 2 squared times 3 squared, because I have 2 3's I'm multiplying. So if I multiplied 2 squared times 3 squared, it would be 36. Now let's say, hey, wait a minute, that's not what I was thinking. Maybe you were thinking 36 was 3 times 12. Okay, 3 times 12. Well, let's see, 3 is prime, and then 12, maybe 3 times 4. Okay, so I'm going to circle 3 because that's prime, and 4 could be 2 times 2. And so I'm done because it's all, the end. It's all ends with prime numbers. So my answer is just these circled ones, okay? So that's 2 squared times 3 squared, because I have 2 of the 2's and 2 of the 3's. So I'm going to get the same answer. It's just I went about it a different way. Okay, let's do some more just to keep practicing. Okay, let's try 90. Okay, you can go about it a lot of different ways. One way I could do is 10 times 9. Okay, 10, a lot of people want to say 5 and 5. 5 and 5 would be 25. Make sure you're careful about that. That's going to be 2 and 5. Now 2 is prime, so I'll circle that. And 5 is prime, so I'm going to circle that. Is 9 prime? No, 9 is not prime. Okay, 9 is 3 times 3. So I'll circle those because those are both prime. So I'm done. So that would be 2 times 3 times 3 times 5. Okay, and I could condense that because this right here is 3 squared, right? So I could say 2 times 3 squared times 5. Okay, let's do another one. let's do 100. Okay, if I did 100, okay, I could start, there's so many ways I could go about this, right? I could say 10 times 10, 4 times 25, 5 times 20. Any of these will work. So if you would like, go ahead and press pause and try it and see what you get, and then see if we get the same answer. Okay, I'm going to do 4 times 25. So 4, I know that I have, 2 times 2, and 2 and 2 are both prime. So I'm done with that. And then I know 25 ends in 5, so that means I can, 5 is a factor, right? 5 times 5. And those are both prime, so I'm done. So notice that I have no more branches left uncircled, right? They all end. And again, my answer is only this part. So that is going to be 2 squared times 5 squared. Okay, that comes from 2 times 2 times 5 times 5. Okay, that's where that 2 squared and the 5 squared comes from. Okay, and we're going to just try one more. We're going to do, let's do 72. Okay, 72. What's something that can multiply to get to 72? 8 times 9. Okay, what can go into 8? 2 times 4, and again, don't say 4 and 4, because yes, 4 plus 4 is 8, but 4 times 4 is 16. So 2 is prime, 4 is not prime, so I'm going to factor that out to 2 and 2. It would help if you could see it. So that's 2 times 2. Those are both prime. 9 can factor out to 3 times 3. And again, those are both prime because there's nothing that can multiply to get to anything besides 1 times 3. So now I'm done. So I can write 2 times 2 times 2 times 3 times 3. But since these are all being multiplied, right, then I can just say I have 3 2's, so that's going to be 2 cubed times, I have 2 3's, so 3 squared. So if I figured out 2 cubed times 3 squared, what's that going to equal? 72. That's what we just did. We figured out what the prime factorization is. So this right here multiplied will equal 72. All right, I hope you are feeling good about prime factorization.